Okay, so here we are talking about decomposition reactions. And decomposition reactions can be a lot of fun, as you will probably see in class. How do I identify them? Well, only one reactant is named. That's how you decide that what you're looking at is a decomposition reaction. One thing is decomposing into multiple products. Typically what we're going to see is two products, but it could be more than that. And how do you predict the products? Well, my suggestion is to identify the anion that's in the reactant. If the anion is a carbonate, then your products are going to be the metal oxide plus carbon dioxide gas, always. If the anion here is a chlorate, then you're going to get a metal chloride plus oxygen gas, always. And if it is a hydroxide, you're going to get a metal oxide plus water, always. And I know you're thinking to yourself, why? Well, why is that Sumo Boy says that's so. And maybe you've never met Sumo Boy, but here he is, right here. So let's take a look at what some of these look like here. If you have potassium chlorate, well, I'm looking at, let me get my writing utensil here. Okay, I've got a chlorate. So I'm going to write potassium chlorate. Potassium is K, chlorate is ClO3. Chlorate's a -1, potassium is +1, so this is the compound. And it's going to decompose. We said from the other side you're going to get a metal chlorate. Potassium here is the metal. So I get KCl. Potassium is +1, chloride is -1, so it's just KCl plus, remember what the gas was? Oxygen gas. Right. So then, to balance it, I've got 2 oxygens over here, 3 oxygens over here, so I'm going to put a 2 there and a 3 there. What does that give me? It gives me 6 oxygens, 6 oxygens. It also gives me 2 potassiums, 2 chlorides, and put a 2 there, and I've balanced the equation. So a chlorate is going to give you a metal chloride plus oxygen gas. How about a carbonate? Sodium carbonate. Let's try this color. Sodium is Na, carbonate is CO3. This is -2, sodium is +1. That means I need a 2 there. And what do we say here? I get a metal oxide. The metal is going to be sodium, Na. Oxide is O. Oxygen is -2, sodium is +1, so that's Na2O plus carbon dioxide. So I've got 2 oxygens plus 3 oxygens over here. 2 sodiums here, 2 sodiums here, 1 carbon, 1 carbon. This is balanced as it's written. All your coefficients are 1. So carbonate, you have metal oxide plus carbon dioxide. How about a hydroxide? Magnesium hydroxide. Magnesium is Mg, hydroxide is OH. Hydroxide is -1, magnesium is +2, so I need 2 of those puppies. And this is going to decompose, it's going to give me the metal oxide, MgO. Magnesium is +2, oxide is -2, so that's written the way it's written there, plus water. Let's take a look now. I've got two oxygens, two hydrogens, and I have two oxygens, two hydrogens here, one magnesium and one magnesium. Slick. A hydroxide gives you, I'm dying, gives you a metal oxide plus water. And finally, here I have a binary compound, nitrogen triiodide, Ni3. This is just two elements. And if that's what you're given, it makes it pretty easy. It tells you you're going to get nitrogen plus iodide. Now, what do you need to remember here? Did you do it? Well, nitrogen is diatomic, so is iodine. And so now if I need to balance this, I'm going to get three iodines, two iodines. I need a 3 there and a 2 there, and we're done. So a binary compound just split the elements into their identities. It's kind of the opposite of a synthesis. Okay? Thank you.